To start, talk to your IT department and/or your internet service provider. You will need to get from them a static IP address for the receiver, the subnet mask, the gateway, and the DNS address. If the receiver is going to be behind a firewall, IT will need to configure port forwarding for port 80 for the web UI of the receiver and a port for correction data. 5018 is the default for an open connection, or 2101 is the default for NTRIP. Connect the NetR9 receiver to your LAN or router with an Ethernet cable and turn it on. DHCP is enabled by default on the receiver, so the network will assign it an IP address. We'll change this to a static IP address later. To check the IP address that's been assigned, press the up arrow on the faceplate of the receiver and record the IP address. Once you've recorded the IP address that the local area network assigned to your receiver, open up a web browser and type that IP address in. And hit the enter button. This will go ahead and open up the web UI for the receiver, and by default security is turned off, so it shouldn't ask you for a username or password. We're going to set that up later on. This is a NetR5 receiver I'm using for this example, but for what we're going to do today, the settings will be the same for a NetR5 or a NetR9 receiver. So the first thing we need to do is go ahead and change it from DHCP to a static IP address that your IT department gave to you, so that the receiver always has the same address and we know where to find it every time. So we're going to go to Network Configuration, and we're going to go to Ethernet, and we're going to change it from DHCP to a static IP. And right here we'll type in the static IP that the IT department gave to us. Then once we've typed that in, you can make any changes that you need to here. Get your IT guys involved if they need to change anything. You can do that. But the main thing is we want to make sure we set a static IP address in here so that the IP address isn't changing on us. So once we've done that, we'll click on Change Configuration, and it's going to let us know that we need to reboot the receiver for this to take effect. So we'll go ahead and hit Receiver Reset, and we'll give it this 1 minute before we try to reconnect. Once we've allowed the receiver to reset, we'll need to type in the new IP address. In order to connect back up to the web UI. Once we type that in, the web UI will reopen. The next thing we're going to do is enable security on the receiver. So we'll click on Security on the left. By default, security is disabled. So we'll click on Configuration. There are two different ways you can enable security. If you just choose Enabled, anytime anyone tries to log into the web UI, they're going to have to put in the username and password, whether they're the admin or whether they're just a user. Or you can use Enabled with anonymous access. If you just have people that need to download data for post-processing or something like that, and you don't want them to have to use a username and password, you can set it up for Enabled with anonymous access and give that person access to file downloads or file deleting, but all the settings on the receiver will be grayed out so they can't change anything. We're going to go ahead and set it up for regular security so that you have to use a username and password. So I'll enable that and I'll click OK. So it's going to ask for authentication. The default username and password is admin and password. These are both lowercase, so we'll type those in, click OK, and now the security's been configured so that we do have security enabled. If you want to change the password, we can go back to security, go to change password. Now for the admin account and having control of the receiver, the username will remain as admin, so we'll type that in, but we can give it a new password. And just repeat that. So now we have the security set up on the receiver. It's going to ask us, since we changed the password, to log in one more time. and we're all set. Now we'll cover how to create users for field use if we're using the InTripCaster and trying to log in from the field. We'll cover that a little bit later. So the next step will be setting up the receiver to log data in order to position the receiver. So we'll go to data logging, and under the default tab we can click right on default, and what we'll need to do is check the box for enable. Now, there's a couple of different ways that you can log data. We're going to use the online positioning user service to position our base station. It requires at least 2 hours of data to get a decent position, and the more data you gather, the better average position you're going to get for your base station. You can use the drop down menu and set it to always, and with it set to enable and always, we'll make sure we're logging a TO2 file. When it's set to always, it's going to log until we uncheck the box for enable at a later time. So it's just going to keep logging data, keep logging data. What I recommend is logging data in a continuous manner, coming in here and setting it to continuous. Set it for 1440 minutes, and that's 24 hours. That way we can log a 24-hour file, it'll stop, start another file, log another 24-hour file, stop, log another 24-hour file, and it'll keep doing that continuously until we turn it off. If you get 3 to 5 days worth, 3 to 5 24-hour files, that's going to position your base station very well. So that's the way I'd recommend doing it. Now when it starts off, it's going to start at whatever time you started at, say noon Eastern time, but then at midnight UTC, that's when it's actually going to start the 24-hour countdown. So you might get a 5-hour file, an 8-hour file, then it'll start a 24-hour at midnight UTC time, and then at 11:59 it'll stop that file, and at 0000 UTC time it's going to start up again. So do at least 3 of those, 3 to 5 days, if you want a really good position on your base station. So continuous 1440 minutes, we'll do TO2. We're going to set it to 15 seconds. That's fine. Again, Opus is going to decimate your data to 30 seconds anyway, so 15 seconds is fine. 5 minute on the positional. We're going to log it internally to the receiver. And for this, I don't really need to change my name style. I'll go with the serial number, the Julian day, and then the file number there. And once we have that set up, we'll click on OK. And you'll see the file is pending. And then it'll start logging data, and it'll tell you the path that it's going to there. Once you're done logging data, you've got your 3 to 5 24-hour sessions. You can log back into your base station using your IP address in the web browser. Go to data logging, and we'll click on default and go ahead and uncheck the box for enable. That way it'll stop logging data. Click OK. We see here now that it's been disabled. And to download those files, we'll go to data files. Click on that. There's the files that have been created. I got a couple of short ones. That's the one that I started the first day, and it didn't get a full 24 hours because it reset at midnight UTC. And this small one here is the leftovers from the day that I disabled it. So I've got 3 other files that I want to download. To download those, I just click on the icon to the left of the file, and it'll automatically start downloading it. Now that I've downloaded my TO2 files, I'm going to open up my File Explorer and just copy them from my downloads to a different folder on my computer just to keep them safe there. So I'm going to go to my documents, create a new folder, and call it base T02. And just paste those files in there. Now that I've got them stored on my computer, I need to convert them to RYNEX, to the RYNEX format, to upload them to Opus. If you don't have Trimble's free Convert to RYNEX utility, you can download it from Trimble's website. So I'll open up a new tab in my browser and go to trimble.com. And once the Trimble website opens up, I'll go to Support and Training, then go to Support A to Z. And under Support A to Z, I'm going to click on the R and find RYNEX in the list. When I click on RYNEX, first you need to download and install the Trimble configuration utility. This has all the antenna models for all the different GPS antennas in it that the Convert to RYNEX program needs to convert your TO2 files into RYNEX. Then after you've downloaded and installed that, you'll need to download and install the Convert to RYNEX program. I already have it on my computer, so I'm going to click on my Start button, All Programs, go to my Trimble folder, and inside the Trimble folder there'll be a Convert to RYNEX folder, and click on Convert to RYNEX. When Convert to RYNEX opens up, I'll go to File and Open and browse to my document folder that I created for my base station files. There's my base TO2 folder. Open it up, and I can select all of them holding down the Shift key and hit open, and you can batch process these and not have to do them one at a time. So it's scanning the files as it brings them in. Once it says complete, then it scans through it, and once all three of them say complete, we'll go back up to File at the top. We don't have to change any settings. Just go to File and choose Convert Files. Now it'll start converting those TO2 files over to RYNEX files, and when it's finished, you'll get a success to the right of each file name at the bottom. Once all three of those are done, then we can close the Convert to RYNEX program. Now I can browse for the online positioning user service in my web browser. I've got it in my favorites. If you don't have it there, easy thing to do is in Google or any search engine, just go to NGS, the National Geodetic Survey, Opus, and if you search there, it should take you right to it. Then I can click on that link, and once the Opus page opens up, I'm going to go to Choose File. Now, the RYNEX converter doesn't give you a choice on where your files are going to get stored. That's why I moved my TO2 files out of my download folder and put them in a separate folder on my computer, because Convert to RYNEX is going to create the RYNEX files in whatever folder the TO2 folders were in. So I'll go to Documents, go to my base TO2, and you'll see here, sort them by type. There's my TO2 files. I've also got O files, 15O, that's just the year, N files, and G files. The only ones you need are the O files. You can only submit one at a time to Opus, but I don't need the N and the G files. Those are my navigation files, ephemeris files. Opus uses its own. So I'll start with the first one, which is 65 here. Just going into the order of the days. Open that. Choose my antenna. With a NetR9 or a NetR5, chances are you're using a Zephyr Geodetic 2, so we're going to scroll all the way down to the T's. And the 55971.00 is a Zephyr GNSS Geodetic 2. So we're going to choose that. We're going to keep our antenna height at 0. That's going to give us what's called the antenna ARP, or the very bottom of the antenna where it's screwed onto the threads. That's where we want our elevation to be. Then I'm going to put my email address in. And we're sending this to Opus Static. Opus Static will handle between 2 and 48 hours of data. These are 24-hour files. So we're going to use Opus Static. Just click on Upload to Opus Static. It's going to warn me here that my antenna height is 0. And it just wants to warn me, make sure I didn't leave it out. I'll click on OK. And then it's going to take a second because these are large files. But once it's uploaded, it'll give us a message letting us know that it's been uploaded. Once your file's done loading, you'll get a message that's saying the upload's been successful. Then you can return to the Opus page enter in any other files. So in this case, we had 3 files. We just load the 3 files. It'll remember your antenna model and your height and your email address, and you'll just need to upload the other 2 files. Now, once you've uploaded those, I've got an example here of one that I got back from Opus. You should have numbers up here. If your base station's out in the open like it should be, you should have numbers up here that are 85, 90% or above on the observations used and the fixed ambiguities. If those are lower than 85 or 90%, you might have some objects close to your base station that are blocking the sky or causing multipath, and you may need to consider moving your base station. The other thing to look for is down under the reference frame. These are what are called peak-to-peak errors, and you can see those are very small. 2 millimeters for the latitude, 5 millimeters for the longitude, 15 millimeters for the ellipsoid height, and 31 millimeters for the orthometric height or the ground elevation. Generally, you want to see your latitude and longitude below 2 centimeters for a good position. In the elevation or in the heights for the ellipsoid height and the orthometric elevations, somewhere below 5 centimeters is good for that, 3 centimeters preferably. So here we've got a pretty good position. A few millimeters on the lat and lon, and a less than 5 centimeters, close to 3 centimeters on the heights. So these are the values that we're going to use. We're going to use under the NAD83 2011, not the IGS-08, but NAD83 2011. We're going to plug this latitude and the west longitude into our base station, and we're also going to plug the ellipsoid height in there. So what you would want to do is get all 3 to 5, however many Opus sessions you did, take those, average those positions. They should be very close again. You should average those positions, and then we'll use those average coordinates to put into our base station. So I'm going to move that out of the way, go back to my base station where we left off at data logging. To enter the position into the base station, we're going to go to receiver configuration. We're going to choose reference station. We're going to put in a name for our base station. I'm going to call this DPI_base. And now I'm going to key in my average reference latitude, longitude, and height from those Opus reports that I averaged together. So my latitude here is 35, 55, 26.64725. My reference longitude, now we're going to use the west longitude that was averaged together from the Opus report, is 86, 52, 4.46251. And then I'm going to put in my average reference height, which in this case was 174.833. And you want to use the EL height from the Opus report, the ellipsoid height, not the ortho height. So once I've got my base station name in, I've got my coordinates in. I'm going to make sure I set that to west longitude. That's very important. So I've got north and west. I've got my latitude, my longitude, and my height. I can click on OK, and the base station has now been positioned. Now it's going to give me a warning that it's far away from the current base. For this section of the video, I didn't have an antenna hooked up to the receiver. That's fine, so we're going to click on OK there. And now our base has been positioned. Once the base station has been positioned, click on antenna to verify that the proper antenna is being used. In this case, we are using a Zephyr Geodetic Model 2, and that's standard for a NetR5 or NetR9. If you need to change it, you can do so in the drop-down list. We'll leave it at a Zephyr Geodetic Model 2. The RYNEX name, the part number for the Zephyr Geodetic Model 2 is fine. Don't need serial numbers. We do want to make sure it's set at the bottom of antenna mount, and we want to leave the antenna height at 0. That way it'll match up just like we submitted the data to Opus. Once we've got that set, click on OK. Next, we'll set the receiver up for data logging for raw data to be used for post-processing in the office in a program like Pathfinder Office. So we'll click on data logging, and then we'll create a new session. We'll give this session a name of RYNEX because what I'm going to do is set it up to store RYNEX data on an FTP site. So then someone that's logging data out in the field with a geo or another mapping device can use this data from the FTP site in Pathfinder Office to post-process their data. So I'll give it a session name of RYNEX. We want to click Enable to start logging data. We're going to set the schedule to continuous, and here we're going to do a duration of 60 minutes. That way it's only creating files that are an hour in length, so that if somebody didn't download or didn't do field work for a full day, they don't have to download a day's worth of data. They can download just the amount of time that they need. Format will be TO2. I'm going to switch the measurement interval over to 1 second for this. Leave the position interval at 1 minute. File system will be internal. Path style we can leave at session and date. We'll want to change the name over to year, month, day, and hour. That's what will work well in Pathfinder Office. And then we'll go ahead and check the box for 1 in our FTP push and tell it to convert the files to, you could do either RYNEX 3.00 with observables and ephemeris, or RYNEX 2.11 with observables and ephemeris. I'm going to go ahead and do RYNEX version 3 and then click on OK. It's going to go ahead and get that set up. While it's getting set up, we're going to go over to FTP push and go ahead and set up our FTP site. So enter the address of your FTP site. Then put in the username and password. Go ahead and verify that. We'll change our path style over to this format, set rename to no, and then we can click the test button to make sure that everything's entered in correctly. This will go out to our FTP site. It will create a folder called RYNEX because that's the session that we created, and then store it inside that folder with this path style. Once it pops up and says OK, we can press OK. We know it went out and did the test and it was able to log in OK. Next, we're going to go to I/O configuration and set up our IntripCaster to broadcast real-time corrections out to the field. So we'll click IntripCaster 1, check the box for enable. We'll leave the port at 2101. I'm going to give it an identifier of DPI base. And then I'm going to give it a mount point, the mount point name of DPI underscore base underscore CMRX. That's the type of CMR, compact measurement record format, that we're going to broadcast out over this port. So next we'll come under CMR, change it over to CMRX. We don't need to change anything else. We can leave everything else the way it is. Click on OK down at the bottom. It's warning me because for this portion of the video I don't have an antenna hooked up to the receiver right now. So now you see in our I/O configuration that IntripCaster 1 at 2101 is set to output CMRX. The next thing we need to do is go back to security and create logins for users in the field to be able to log into our base station and get that CMRX correction over port number 2101. So we'll come to configuration and we'll add a user. I'll create a username for myself. Put a username in and a password. And for this user, I'm just going to give access to the IntripCaster. That way they can get those broadcasts out in the field. So in your software on your data collector, your geo, whatever you're using, this is when you go to set up your login. This is the username and password that you put in. So I'll click on add user there, and then I could just go back through security and configuration, and I can keep adding as many users as I need to. The last step for setup would be to have IT to forward port 2101 to a public IP address so field users can access the corrections from the nTripcaster. For TerraSync or Access setup instructions, see our Success Center videos on configuring TerraSync for VRS data collection or creating a GNSS contact in Trimble Access.